I highly recommend the PhET simulation, Build an Atom. So if you go to your internet browser and type in Build an Atom PhET, P-H-E-T, then you will find a link for this simulation from the University of Colorado. So it's a free simulation, and I highly recommend that you hop on there, press play, and start with the box that's on the left, press that one, and start to build an atom. So I'd like you to play around with the bins of protons, neutrons, and electrons that are on the bottom of the screen and start dragging them into the space for the atom. Hopefully you can notice where each particle goes in the atom, and also take a look at which particle is actually causing the element to change. So if you pull in one proton, it says hydrogen. If you pull in one neutron, does it change the fact that it's hydrogen? Or if you pull in one electron, does that change the fact that it's hydrogen? What if you pull in two protons? So now you have two protons in your atom. Is it still hydrogen? Okay, so hopefully you've noticed that the number of protons identifies the element, right? That's really how we know which element the atom is representing. So we've discovered there then that, and let's actually, if you're on the simulation, build yourself an atom with 3 protons in the middle. And if you have a look at, if you click charge, there's a little box there for charge, then you'll see that it says that the overall charge is +3. So each proton has a charge of +1. Now we can bring in some neutrons. Maybe I'll make my neutrons green. And if you click the stable or unstable box in the bottom right there, you'll notice you have to pull in about 3 neutrons, I believe, for the nucleus to be stable. And if you pull in a 4th neutron, it's still stable. Okay, so that shows us there that we can have nuclei, so a nucleus, with the same number of protons, which means it's a certain element, and a different number of neutrons. So it's possible for this atom here to have 3 protons in the nucleus and 3 neutrons and be stable, or it could even have 4 neutrons and be stable. All right, and as you start to pull the electrons in, you'll notice that the electrons place on one of the circles around the center of the atom. And so we'll position an electron here. And if we pull a second one in, you'll notice that it goes to the shell also, that first shell. And when you pull a third one in, it actually then moves to the second shell. Okay, so let's discuss some terminology here. We've learned that these positive particles in the middle of the atom are called proton. The symbol for that, by the way, is a lowercase p with a positive superscript. We've learned that the neutral particles in the center here are called a neutron. So their symbol is N with a superscript of 0, indicating that they're neutral. And we've learned that these negatively charged particles here are called electrons, and their symbol is E with a -1. All right, so what do we call the location of these? Like, where are we finding these particles? It certainly looks, the way that I've done this, that the cluster of protons and neutrons, right, is in the center of this atom. I would just like to let you know that if you were out on a football field, that this cluster of protons and neutrons would occupy about the size of a ping pong ball. So like even smaller than your fist, you know, that's kind of how much space this would take up compared to the rest of the atom where you would find the electrons. That would be like the rest of that soccer field, the rest of that football field. So even though I had to draw it a little bit bigger so I could see these particles, let's keep in mind that this center of the atom, this cluster of protons and neutrons, is actually packed into a very, very, very small center of the atom. Okay, it's very small compared to the rest of the atom here. All right, so this center of the atom here we call the nucleus. So the protons and neutrons are found in the nucleus. And what do we call these circles that are the location of the electrons? Well, Bohr called these orbits, so you could call it an orbit or a shell or an energy level. All right, now something else to notice about these particles. You have a mass, actually in the PhET simulation, it'll be the second box. So now not the box on the left when you first open the simulation, but the middle box. I think it says symbol. If you go and play with that, you'll start to notice, right, and pull protons and neutrons and electrons in and out of the atom and see what changes the mass. So build an atom that has 3 protons in the middle, okay, and 4 neutrons and 3 electrons, and keep track of the mass. So notice how the mass is changing. Now, it's telling you that this is an atom of lithium, right, with 3 protons, atomic number 3 for Li. Can you keep this atom, still be an atom of lithium, but now make it have a different mass? So on this PhET simulation, right, don't change the protons because that's what makes it lithium. Aha, if you change the neutrons, you're going to notice the mass changes. So the idea here is that most of the mass of the atom is found in the nucleus. So we'll just make a note of this. And you can actually get the mass of the atom by adding the number of protons and neutrons. It's not the mass in grams, but it's a relative mass, so it gives us an idea of how heavy one atom is compared to another. So the mass, right, comes from adding those protons and the neutrons. Okay, what about the mass of the electrons? Well, imagine you step on a scale at home and it shows you, or at the doctor's office, and it shows you what you weigh. And then there's a fleck of dust on your shoulder. So go ahead and brush that fleck of dust off your shoulder. Did the reading on the scale change? No way. There's no way that fleck of dust that's so light compared to your body's mass, right, is going to alter the reading on that scale. That scale would have to be reading to a huge number of decimal places to pick up the change in mass due to that fleck of dust. And that's what's happening in the atom. Does an electron have a mass? Yes, it actually does. It's just a really, really, really small mass, okay? And it's really small compared to the mass of these protons and neutrons. So the electron is essentially like the fleck of dust on your shoulder. You brush it off and it doesn't really change your mass. These electrons are so light compared to the protons and neutrons that we really say their mass is negligible, and we focus in on the protons and the neutrons to get the mass of the atom. Okay, so just to review, we have learned the names of the particles that make up an atom. So we call them subatomic, so within an atom, subatomic particles. We have protons in the center, which we call the nucleus. They are positively charged. Neutrons, which are also in the nucleus and have no charge, they're neutral. And then we have electrons found in the orbits or shells or energy levels of the atom. Now, we also notice that the element that the atom is representative of, right, comes from the number of protons. So let's just be making a connection here back to what we learned. We learned that atoms or elements are positioned on the periodic table according to their atomic number. And so now what we're learning here is that the atomic number is the number of protons. And this tells you the identity, right, of the element. So the fact that this has 3 protons makes it a lithium atom because the atomic number for lithium is 3. The number of protons is the atomic number, and that tells you the identity of the element. Change the number of protons, and it's not going to be lithium anymore. Change the neutrons, and you just gave the lithium atom a different mass. Okay. All right, so that's pretty useful in terms of knowing the structure here. Okay, so we also have something called element notation or standard atomic notation. This notation Okay, this notation, this element notation or atomic notation, has a symbol in the middle. So I'll give you an example here of that lithium atom we were drawing. So it has the symbol of the element with a number in the bottom left. That number down there represents the atomic number. So this is the atomic number, which I'll remind you is the protons. And then it has a number up top. Now, where did I get the 7 from? 1, 2, 3 protons plus 1, 2, 3, 4 neutrons. Protons plus neutrons equals the mass. So this number up top, right here, right, this is the mass. So we have the element symbol, and then the two numbers involved show us the atomic number and the mass. Okay. So from that, the other thing I should point out is that if there is a charge to the particle, then the charge will be written in the top right. Okay, so this is where the charge would be shown. Now, the charge in this case happens to be 0. So let's recognize right away here that atoms are neutral. So what does it mean for an atom to be neutral? Well, it has the same number of positives and negatives. See these 3 positives up here? If you played with the PhET, every time you pulled in an electron, right, it brought negative charge into the atom. So we have 1, 2, 3 electrons, right? That's what these are here, 3 electrons, and they are balancing out the 3 positive charge. So overall, there's no charge. And that is what when we say a particle is neutral. When is it neutral? When the protons and electrons are the same. So atoms are neutral. And you can see that 3 protons, 3 electrons. In a different atom, maybe there's 10 protons. That means there's going to be 10 electrons. For atoms, the protons and electrons are always equal. Okay. So if I give you a notation, right? That's what I'm going to do here. I'm going to give you a notation. And I'd like you to state the number of protons, neutrons, and electrons. Okay, so write that down. So in this question, we'll do part A. Here's a sample. So C, 13 here, and 6 here. Okay, so use what you've learned here, right? The bottom number is the atomic number. That tells you the protons. The top number is the mass. Remember, the mass is the protons and the neutrons. So you're going to try, this is the protons and the neutrons, and this is the protons. We're trying to figure out the neutrons from here. And then, remember, if there's no charge, then the atoms, it's neutral, right? So protons has to equal electrons. All right, so I have a look here, and this number right here tells me 6 protons. Okay. Now, if the protons are 6 and the total mass is 13, what's the difference here? Because the difference is going to be the neutrons. So I'm going to subtract these here, right? So 13 minus 6 is going to be 7. So there's 7 neutrons. And because there is no charge written here, that means the protons and the electrons are equal. All right, so if I had 6 protons, then I now have 6 electrons. Okay, so that's what I'm asking you to do, is look at each question and state the number of protons, neutrons, and electrons. All right, so give these a shot. I've got an atom of calcium here, atomic number 20 and mass of 41, and then iodine. Okay, so take a moment, pause the video, and try to state the number of protons, neutrons, and electrons for each of these particles. And when you're finished trying the question, then turn the video on again and see if you were right. Okay, so to check your answers, atomic number tells us the number of protons, 20 protons. We subtract here the mass minus atomic number. I'll just write that what I'm doing here. To find the neutrons, I'm doing the mass minus the atomic number, right? Remember, the atomic number is the protons, so When the mass comes from the sum of the protons and neutrons, you can find the neutrons by doing mass minus that atomic number. So 41 minus 20 gives us 21 neutrons, and then again, no charge here, so the protons and electrons are the same. Do the exact same thing with the iodine notation here. 54 protons, 127 minus the 54 gives us 73 neutrons, and 54 electrons to match the 54 protons because there's no charge. So this is a neutral atom of iodine. Alrighty, so what happens if there is a charge there? Let me give you another example here. All right, so this will be example 2. I want you to do the same thing. State the protons, neutrons, and electrons. Okay, so in question A, I'm going to have this symbolism, but look what I'm putting here. Positive, or I guess I'll write positive 1. Maybe that'll be easier to understand there. Okay, so let's do this one together. We still are going to look at the atomic number, right? Still going to look at the atomic number here for the number of protons. And for the neutrons, we're still going to subtract. So 23 minus 11 gives us 12 neutrons. All right, now for the electrons. We have 11 positive particles, right? And there's a charge here of +1. So we have one more positive charge compared to the negatives. If the protons are positive, that's saying we have one more positive compared to the electrons. So 11 protons, right? And 10 electrons. So compare the positive to the negative. See how there's one more proton? That's the extra positive 1 charge. Okay, let's try a different one. Let's try a nitrogen ion, which has a charge of -3. And atomic number 7 will go with a mass of 14. So try this one. State your protons. Go ahead and subtract mass minus atomic number to get your neutrons. And now to compare the protons and electrons to figure out the number of electrons, to get your charge. So the charge here is -3. So that means we've got 3 extra negative particles. So there's 7 positive here. So we'll need 10 electrons. Does that make sense? Compare the positive to the negative. What do you have more of? You have more electrons, right? And how many more? 3 more, because 7 plus 3 would be 10. There's 3 more electrons, and they have a negative charge. So -3 is the charge. Now, just to let you know, it's totally fine, and you will see this, okay, for this charge to be written with 3 negative like that. Okay, so whether you write it -3 or 3 negative, I'm okay with either of those. Okay, I'll give you one more here to try. You can try this ion, and again, I'm looking for you to come up with the number of protons, neutrons, and electrons. So give this question a shot, pause the video, and then you can turn it back on to see how you did. Okay, bottom number, the atomic number in this notation tells us the number of protons, mass minus atomic number to give us the neutrons, and then the number of electrons, right? I'm deciding this based on this charge and the number of protons here. If there's 12 positive particles, right, in order for this charge to be +2, that means that I've got to have, this has to be 2 more than what I have here. Compare the negatives to the positives. See how there's more positives? How many more? 2, right? 12 is 2 more than 10, so there's an extra +2, and that's why you see the charge here. So I purposely told you about the build an atom FET. You should be able to go and build a particle on the FET that has 11 protons, 12 neutrons, and 10 electrons. And you will see that it's a sodium ion with a mass of 23 and a charge of +1. Same thing for each of these particles. There's a game in the PhET, so the third box, like the PhET, when you first open the PhET, right? I think it says atom here, and then the middle one says symbol, so that's where you were playing around with what we were just doing here. And then the third box actually says game. So go ahead and click the game and play around, right? Try those questions, have some fun with it and learn something and check your understanding. And if there's any question that you're not sure why it is the way it is in that game, then take a screenshot of that or copy it down and come on in and ask me and we'll work it out together. Just a quick insert here. I forgot to put a term here, right? So we talked about atoms being neutral. I'd just like to point out that these ions, right? These are all ions. Ions have, they have a charge. Okay, so ions have a charge. It might be positive, it might be negative. But the key is the protons and the electrons are not equal. Okay, protons and electrons are not equal. So just like you getting comfortable with this term ions, recognizing that you're going to have a charge. If you see a charge, it means it's an ion. If the protons and the electrons are different, it means it's an ion. Okay, ions have a charge. Might be positive, might be negative. If you have more positive particles, the charge is positive. If you have more negative particles, the charge is negative. Over here we have more positive particles, the charge is positive. So, where atoms are neutral, ions have a charge.